In this lecture, I'm going to explain how statements are represented in propositional logic. And so I'm going to, and I'll show how they can be represented with Venn diagrams. So basically, I'm going to start out with the simplest statements, and then I'll build up gradually, so I'll just do it step by step instead of talking, abstractly about the whole thing where you get totally lost. So I'll start with the basics. Propositional logic, the basic elements of propositional logic are going to be letters. They're going to be capital letters. And I'm going to be using P, Q, and R because I'm not going to go beyond 3 letters because I'm going to be showing how Venn diagrams can be used to represent them. And Venn diagrams have 3 circles. So let me, the simplest statements in propositional logic are going to be individual statements. For example, P. The letter P is what's called an atomic statement. It's the simplest formula that you can have in propositional logic, or individual letters like P, Q, and R. These are called atomic statements because they're the atoms or the simplest elements out of which propositional logic, the statements of propositional logic can be formed. From these atoms, you can build up using connectives, which I will go over in a second. But these are the simplest. They stand for simple statements. Like I can say, let's say, for example, I can say P equals today is Monday. Let's say Q stands for it is raining. And Q is there is class. There is class today. So referring to you're in school and you have a class. These are the simplest statements in propositional logic, P, Q, and R. They are what are called, and I'm going to introduce this term now because it's going to keep coming up a lot, they're called WFFs. A WFF is an abbreviation for well-formed formula. Well-formed formula. And if you have more than one, then you have WFFs. They're called WFFs. So when I use the expression WFF, what I'm talking about is this, things like this. P is a WFF, Q is a WFF, and R is a WFF. Every statement, every meaningful statement in symbolic logic is going to be, in propositional logic, is going to be a WFF. Often these are referred to as sentences. Okay, so many logic books will refer to a sentence. Some will refer to statements. Some will refer to propositions. They all basically mean the same thing. Every meaningful sentence, every meaningful statement, every meaningful formula in propositional logic is a WFF. It's a well-formed formula. If something is not a WFF, a well-formed formula, it doesn't mean anything in symbolic logic. It's meaningless. It has nothing. You can't do anything with it. The simplest WFFs, the simplest well-formed formulas in propositional logic are the atomic WFFs, the atomic statements, P, Q, and R. That's the ones I'll be using, those letters. I'll stick to those. So P is, and I'm going to make it in today, P is going to stand for, it's going to represent the statement, today is Monday. Q is going to stand for it is raining, and R is going to stand for there is class today. These are all meaningful sentences in propositional logic. I'm going to erase this here, atoms, okay? This atomic statements. These are all atomic statements. Every meaningful statement is going to be, I'm just going to be using P, Q, and R. Every meaningful statement is going to be made out of these atoms. So we can add things to them, and these are called connectives. For example, if I want to say, if today I could use this symbol here, it's called the tilde. It's a sign of negation. It means it is not the case. It is not the case that. It is not the case that. So for example, if I put a tilde, a negation sign in front of P, this would mean it is not the case that today is Monday, or, today is not Monday. If I put a negation sign in front of Q, it means today it is not raining. It is not the case that it is raining. If I put a negation sign in front of R, it would mean there is no class today. It is not the case that there is class today. When you do anything, when you add any symbols to these letters, you no longer have an atomic statement. You now have a compound statement. So these are compound statements, not Q and not R. I mean, these next to this, and this, these atomic statements, the simplest statements you're going to get in propositional logic would be these here. But these are compound statements. They're all made out of this. So I'm just going to stick at this point. Later on, I'm going to introduce different symbols. I'll introduce this, the V or the vel. It's going to stand for or. The ampersand is going to be and the arrow is going to be if then. Okay, and I'll stick with this. But I'll do this later. Okay, but right now I'm going to stick with the negation sign, the tilde. TILDE. That's what that's called, the tilde. These statements are called statement letters or sentential letters. I'll refer to them as statement letters. Every statement letter is going to be true or false. Propositional logic is truth functional. I'll explain that in a second. But first of all, we're going to start with the very basics. If you take any letter, statement letter, take P, for example, it's either going to be true or false. And I'll use T for true and false, F for false. And I'll put a 1 and a 2 here. So these are two possibilities. I'll number them. This is what's referred to as a truth table. A truth table gives you truth values. If you have one statement, one atomic statement, say P. P can either be true or false. It has to be one or the other. Now, whenever you have, if I, let's say I put a negation sign in front of it, it's not P. Let's say this stands for today is Monday. Today is not Monday. Here's how this is going to work. This is a truth table. If P is true, the rule for the negation sign is that if you put a negation sign in front of a statement letter, what happens is you reverse the truth value. So T becomes F, and F is going to become T. And this is it makes a lot of sense. Think about it. If today is Monday is true, today is not Monday has to be false. You switch. If it's false that today is Monday, if today is Monday is false, then it's true that today is not Monday. So this is the simplest operation really you can do in propositional logic is just negate statements, the truth values. Now, so I'll cross out the U and the R. I'll just stick with the today is Monday here because I want to draw some other stuff here. So I'm going to show you now how I'll put one circle here and I'll put a box around it. So we're either inside or outside the circle, and I'll call this P. Let me put this over to the side because I have more room here then. So P, not P. P can be true. it would be false. If P is true, not P is false. If P is false, not P is true. Okay, that's a truth table. This circle here, it's not really a Venn diagram. The Venn diagrams really have two circles, but we'll start with one circle just to show how it works, and then I'll add two circles, add another circle. Inside the circle means, here's how, this is very important. You're either here or here. If you're here, what that means is that P is true. I'll put it like that. That's what that means. P is true. If you're outside the P circle, this is the P, I labeled it the P. It's the P circle. If you're outside the P circle, P is going to be false. Okay? P is false. That's what these two sections mean. Okay? Now, that's absolutely fundamental to know, because if you don't know that, the rest won't make any sense. Inside, basically the idea is this: inside P, inside the P circle equals P is true. Outside the P, I'll just say outside P, I mean outside the P circle, means P is false. Inside P is true, outside P is false. Now, I'm going to draw two circles. I'm just going to, just so we understand what's going on here. I mean, this is very important. We're not going to do a lot today. I just want to make sure we understand what's going on, then we'll build on it. We have two circles here. I'm going to go over what each section means. We have 1, 2, 3, 4. Each of these numbers is going to correspond to a line of the truth table. Let me do this really fast, and in next lecture I'll go over it again. If you have two statements, P and Q, you have four possibilities. P can be true, Q can be true. They can both be true. That's line 1. P can be true, Q can be false. P can be false, Q can be true. Line 4, they can both be false. It's just like basically if you have a penny, you could flip it. 2 pennies, you flip it. You could have heads, heads, tails, heads, 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 tails, tails, heads, tails, tails. With two statements, if you have two statements, they can both be true. P can be true, F false, P F false, Q true, or they can both be false. Section 1, this section here corresponds to line 1 of the truth table. So section 1 of the Venn diagram means that P is true and Q is true. Because look, we're in the P circle and we're in the Q circle. Inside the circle means it's true, outside false. So section 1 means that P is true and Q is true. Section 2, we're inside P, P is true, we're outside Q, Q is false. Section 3 of the Venn diagram means we're outside P, so P is false, and we're inside Q, Q is true. And section 4 is out here, the section outside the two circles, they're both false. We're outside P and we're outside Q. So this is a picture of this. Okay, that's the first thing I want to. It's very important. This doesn't tell you. It just tells you what the sections mean. Okay, that's all it tells you. But that's the beginning. From this, we're going to build up. We will be able to diagram any statement in propositional logic. Okay, so that's all I'm going to say for today. In next lecture, I'll start from here, and I'll develop, so step by step. So, but within a short time, you'll be able to. This will be simple, very easy for you. Okay, that's all for today.